If you've ever managed a project, you may be familiar with the term critical path method, or CPM scheduling. In this video, we'll cover the key components of CPM scheduling and show you exactly how they come to life inside CPMCAD. For a deeper dive into CPM theory, there are plenty of great resources available online. But here we'll focus on what you need to know to build and understand a schedule in CPMCAD. At its core, CPM scheduling is about understanding the sequence of activities that drives your project's finish date. Every activity has a duration, and activities are linked to one another through their relationships, forming a network that tells you not just what needs to happen, but when each activity must occur to keep the project on track. CPMCAD calculates this automatically. Every time you update the schedule, it runs a forward pass to determine the earliest possible dates for each activity, and a backward pass to determine the latest allowable dates without delaying the project. All you need to provide is an activity ID, activity name, a duration, predecessor relationships, and any date constraints. Enter those into the Excel template and CPMCAD handles the rest. Relationships are the links between activities and CPM scheduling. They define the order and dependency of your work. CPMCAD supports all four standard relationship types. Finish to start is the most common. Activity B can't start until activity A finishes. This is the default handoff between most tasks. Start to start links the beginning of two activities. One can't start until the other is started. This is useful for overlapping work, like earthwork and drainage installation, running in parallel. Finish to finish ties the completion of two activities together. One can't finish until the other does. Start to finish is the rarest type. One activity can't finish until another starts. It's a specialized relationship, but CPMCAD supports it fully. In CPMCAD, you enter relationships directly in the predecessor column of the Excel template, using the activity ID of the predecessor, followed by the relationship type. For example, W1010FS for a finish to start from activity W1010. Any relationship can include lag, additional time inserted between two connected activities. Consider a public bid period. Advertising the project and holding the pre-bid meeting might share a start-to-start relationship with a 5-day lag, meaning the pre-bid meeting is scheduled 5 days after advertising begins. On the other end, a deadline for submitting questions might have a finish-to-finish relationship, with a negative lag of 7 days to the close of the bid period, ensuring questions are due 7 days before bids are received. Negative lag is often referred to as lead time or simply lead. You enter lag directly in the predecessor cell. For example, W1600SS plus 5 for a 5-day lag, or W1600FF minus 7 for a 7-day lead, and CPMCAD incorporates it into the calculations automatically. Sometimes network logic alone doesn't capture the full picture. Real projects have fixed dates, contract milestones, permit windows, owner requirements. That's where constraints come in. A finish no later than FNLT constraint tells the schedule that an activity must complete by a specific date. If the network logic pushes that finish past the constraint date, CPMCAD flags it with a negative float value, shown here in magenta, signaling a conflict that needs to be resolved. A finish no earlier than FNET constraint does the opposite. It holds an activity's finish at or after a specified date. This is useful when a deliverable can't be submitted before a certain milestone is reached. In CPMCAD, you can apply constraints using the constraint type and constraint date columns in the Excel template. The engine propagates them correctly through both passes of the calculation. Once the calculations run, every activity has a total float value, the number of days it can slip without delaying the overall project finish. Activities with zero float form the critical path, highlighted in red in CPMCAD's network diagram and Gantt chart. CPMCAD also calculates free float, how much an activity can slip without affecting its immediate successors, even if the project finish isn't impacted. Keeping an eye on float is how you stay ahead of schedule risk. Zero float activities are your critical path. Any delay there directly impacts your finish date. But don't overlook activities with just a small amount of float. A 2-day delay on an activity with 2 days of float is just as damaging as a delay on the critical path itself. And CPMCAD's color-coded Gantt and network diagram make it easy to spot those vulnerabilities before they become problems. That covers the key building blocks: relationship types, lag, constraints, and float, and how each one is entered and calculated inside CPMCAD. For more on any of these topics, check out the other videos in this series or visit cpmcad.com.